Hi there and welcome to my channel. In this video my topic is limits, and I'm really going to discuss the continuity aspect of it and the discontinuity aspect. This is done in pure math and usually in lower 6 module 3. So please stay tuned to see all my definitions and the few examples that I go through to explain exactly how you dissect the question that covers this topic. So the first thing I want to do is define the limit. The limit of a function is defined as the value the function approaches at a given x value, right? Now, for a limit to exist, a few things must apply. The left-hand limit must exist, the right-hand limit must also exist, and the left-hand limit and the right-hand limit at x is equal to a must be equal. So the left-hand limit looks like this, where x is equal to a. For the minus, you have to signify it's coming from the left. The right-hand limit would look like this, limit x goes to a with a plus f of x, and the third point says that they must be equal. So for instance, if I had a graph like this, and say this point here was 2, 2, and this point here was 2 minus 1, then what I can see from this side is that the limit as x approaches 2 from the left, that's from this side here, is actually of f of x will actually be 2. That's this 2 here to be equal to. Whereas the limit as x approaches 2 from the right of f of x will be minus 1. Now what's happening here? The left hand side is not equal to the right hand side. So therefore I will say the limit does not exist. I hope you all understand this. Right? So now let me move on to continuity and discontinuity. Now, in simple terms, continuity simply means that there's no break in the code. For example, I can have a code going like this. There's no break. There's no hole or anything like that, right? It's one smooth, nice code. That code is continuous. So the definition of continuity goes like this. F of a has to be defined. That means it must be a value that is in your domain. The limit of f of x as x tends to a must exist, and eventually what are the criteria to make something exist, make a limit exist. And the limit of f of x as x tends to a must be equal to f of a. So for these three conditions to hold, then we can have continuity. If any one of these conditions is not met, then the function is not continuous. So this is my first example where I want to ask you, is this graph here continuous? Now we're seeing a nice straight line, it looks good. However, there's a hole here, and that hole exists where x is equal to a. So what's actually happening with this is that in the domain, a is not defined. So because a is not defined, then f of a, well, is undefined. So then that means this condition was failed. So then this graph here, this function is not continuous. Now, if I went on to ask a question for this particular graph here, is this function continuous or not? We'd have to look at it, how it's drawn. Now, it's a nice connected line here with a solid point here, and then there's a hole here with a line like this. Now, what I'm seeing here is that when it goes to the left of a, it approaches a value, and when it goes to the right of a, it approaches another value. So this means that f of x as x tends to a cannot exist, because the limit x tends to a from the left of f of x is not equal to the limit x tends to a from the right of f of x, because we're seeing this here going on, right? So this graph is not continuous. Now say if this was our third graph now and they ask us the same question, is this continuous, right? So the first thing we would do is we have to analyze how the graph is drawn. It's a nice solid line here, all the points here are connected, and same for here. However, there is a circle here and it's not filled. But there's a circle here and it is filled. So it means at this point when x is a, it is when I substitute x is equal to a, I will not get the value for here, which would be what I would have expected. It actually will work out to be here, right? So what this is telling me is that my limit as x tends to a of f of x, that is going from the left and going from the right, should have been this white circle here, is not equal to f of a, because f of a is actually the blue circle. So because these two sides are not equal, then it is not continuous. So from there now, I could go to the types of discontinuities, right? So there are three types of discontinuity. This one is really point discontinuity, and this one is removable, meaning that if I just define the f of x function at a, then it will be removed and the function could be continuous. This one is called jump discontinuity because it's obvious there's a jump here. And this one is called infinite discontinuity because there's an asymptote here, right? Now, these two are not removable, whereas this first one is the only one that is removable. So I will call this example 1. And this is my function here. It's defined, it's called a piecewise function where it's defined in pieces. This is one piece, and one piece. My first part says to sketch, and then it says to determine if the function is continuous at these 2 points, right? So to sketch this now, I would actually have where x is less than 1. Say this is minus 1. My curve may go like this, like a straight line like that. Then it's x squared from minus 1 to 2. So say 2 is probably around here. So we'll go like this, and then it'll go up like that, right? We'll have a solid dot like that. And then for this part here, it's 2 where it's greater than 2. So say this is where 2 is or so. I will have here now like this, right? So this is at 2, this is at minus 1, this is where y is 2, and so on. Of course, with your arrows and so on. So this is my definition of sketching it, right? This is how I would sketch it. Now, of course, I didn't go through all the workings because I think you all should know how to do that, right? Now, if I have to do part B now, which is really what this video is about, is to determine if the function is continuous as x is equal to minus 1. Now, at minus 1, what's happening here? Now, I'm seeing a solid dot. As x approaches minus 1 from the left, it approaches this value here, right? And as x approaches minus 1 from the right, f of x approaches this value here. So then what will I say? To put that in working, I'd say the limit as x approaches minus 1, say from the left, will be, I will have to use this function here, so it'll be minus 1 plus 3. Sorry, let me put in the function itself, and then I'll substitute. It will actually be minus 1 plus 3 and 2, which would be 2 and 2, which would be 1, right? Now, similarly, from the right now, the limit as x approaches 1 from the right would actually follow with this function here with x squared, because it'll be going this way, right? I hope you all are understanding. From the right, I will have to go to this function here. From the left, I will have to follow with this function here, right? Because this one here is the x plus 3 and 2. This curve here is the x squared, and this straight line is the 2, right? I place in some some colors here, so hopefully it will be easier to follow. Now, if I have to go from the right, that means I'll have to follow this function here. So then I'll have to put in, sorry, I have to put a minus here. Minus 1 here squared will be 1. So I am seeing from the left and from the right, they are both 1. So it does exist, and so it is continuous, right? So yes, it is continuous here. Now, part B, when x approaches 2. Now, if x approaches 2 now, from the left, as a green curve here, it will actually be closer to 4. But if x approaches y from the right, here, it will actually be closer to 2. So what's happening is the limit as x approaches 2 from the left of f of x is not equal to the limit x approaches 2 to the right of f of x. And hence, this function is discontinuous at x is equal to 2. So this is my second and final example, and it says here, if f of x is equal to the mod of x over the mod of x squared minus 4, then find the real values of x for which the function is continuous. Now how the solution will go, we say the function, this is continuous when the denominator is not equal to 0. So what is my denominator? That's here. Mod of x squared minus 4 is not equal to 0. So what ends up happening here, if I send this over, I know it looks strange, but don't worry, just keep working. It's not equal to 4. So then if I take off the mod, I will get x squared is not equal to 4. So then hence x is not equal to the square root of 4, which will actually, well, the square root of it is equal to plus or minus 2. So hence, this is my answer. F of x is continuous when x is a real number and x is not equal to minus 2 or minus positive 2, right? This can also be stated as x is a real number, but x is not a member of minus 2, 2 values, right? So this takes me to the end of my video. I hope that you have understood the basics from the definition of what is a limit, what is continuity, what is discontinuity, and a couple of examples. So please feel free to share, subscribe, like. Thanks guys.